In previous videos, we talked about one of the authentication types, which is no, and we talked about passwords and how to properly create a password and store it. Now we're going to talk about additional authentication types. The first one is something you have. So when you're thinking about something you have in your possession, it's going to be like your phone, a card, or an access token. And each of these are used to give us additional ways to get access, whether it's physical access to a building using a key card or an authenticator code that we receive. The next authentication type is something you are. This is a trait. This would be like your fingerprint or your facial recognition or your iris scan or even your DNA or the way that you smell. And another authentication type is what you do. So your behavior, the way you speak, the way that you write your signature, how fast you type on the keyboard, or even the way you walk. Referring to the way you walk, researchers actually built this hallway that would track the way you walk as a part of authentication. The problem was if you had someone that was injured or that was pregnant that drastically altered their way of walking, this could lead to problems with that particular authentication type. So for the next part, we're going to be talking primarily about something you are, and that we will be looking at specifically biometric authentication systems. So the way that a biometric authentication system works is that you have your initial enrollment. So for example, with this initial enrollment, you're going to touch your finger to your device to do that initial scan. And it will ask you to put it in multiple positions and multiple angles to be able to get a conglomerate of all the features of your finger. From this, you get the key features, and those are extracted into what is called a user template. This template is stored into a database or on the individual device. And then for any subsequent access, we're going to scan our finger or whatever it is, face, iris again. And it's going to extract those same key features to be able to get the user access data. And it's going to compare that with the template. Now, because of the nature of your finger, it's not going to necessarily get the exact same user access data, but is it close enough? And if the answer is yes, it will give that person access to whatever they're trying to gain access to. So when we're looking at biometric authentication, we consider three pieces: verification, identification, and watch lists. So for verification, the supplicant claims to be a particular person. So is the supplicant who he or she claims to be? We're going to compare that access data to a single template, and it's good for replacing passwords. So the probability of the template match is our probability of false acceptance. So let's say the probability of our template matching is 1 in 1,000. That means I have a 0.1% chance of a probability of a false acceptance. For identification, the supplicant does not state his or her identity, but what we're going to do is compare the supplicant's data to all the templates to try to find the correct template. This would be good for door access, for example. So the probability of false acceptance is going to be equal to the probability of the template match, which we already deemed as 1 over 1,000, times the total number of templates. So if there's a total of 500 templates and the probability of matching is 0.1%, that means there's about a 50% chance of false acceptance. The next is watch list, which is a subset of identification. So as you can see, this is identical to identification, except for instead of looking at the total templates, we're looking at the total templates in the watch list. So let's say that there were only 10 templates in the watch list. This would mean that we'd have a 1% probability of false acceptance. So now I want you to try this on your own. Assume the following 500,000 records with a probability of matching at 1 over 2.5 million, and then 1,250 records in the watch list. Answer the following questions, and then come back to compare your answers. All right, welcome back. So what is the probability of false acceptance for verification? Well, we're going to do the 1 over 2.5 million, which is going to be point and then 6 zeros and then a 4, which is equivalent to 0.00004%. So what is the probability of false acceptance for identification? Well, we're going to take that 0.00004% and multiply that by the 500,000 records, and we get 20%. What is the probability of false acceptance for watch lists? We're going to take that same probability of false acceptance and multiply it by the number in the watch list. So the 0.0004% times 1,250, and that's going to give us 0.05%. So what is worse, false acceptance or false rejection? And the answer here is it really depends. For verification for computer access, false acceptance is just a security violation, and it's inconvenient to have a false rejection. If you're looking at identification for computer access, false acceptance becomes a security violation in that we're accepting people to have access to the computer when they shouldn't. A false rejection, on the other hand, would just result in inconvenience. You just have to try again. For example, I'd have to put my finger on the device again. For watch list for door access, a false acceptance again is a security violation, meaning that someone has gained access to a building that they shouldn't have, whereas false rejection just means you have to try again with your card. It's inconvenient. However, a watch list for terrorists, a false acceptance is an inconvenience. For example, as someone's boarding a plane, if we accept a person as a terrorist, it's going to be inconvenient for them to be pulled into another room and to be patted down or investigated or asked a few additional questions. However, if we have a false rejection for a terrorist, we have essentially enabled this terrorist to gain access to whatever it is that they shouldn't have access to. This last question is, can you think of any other issues with biometric authentication? Well, what if someone burned their fingers on accident or on purpose? That could change their fingerprint. Or if they shaved their face and they used to have a big beard. Some systems are pretty good at detecting faces even with the presence or absence of a beard. So biometrics could potentially be changed. An additional thing is that once you enroll your fingerprint, it is a permanent enrollment, meaning that you really can't change your fingerprint unless if you burned yourself or something like that. So once your fingerprint's in the system, anyone who has access to those details will be able to then use those details to log in. And the final authentication type that I want to talk about is where you are. So if you're normally at your home country and you never travel around anywhere, and all of a sudden your account is noticing a login from some other country that you've never visited, systems can be programmed to detect these changes and send notifications asking the user to verify whether or not they truly intended to log in from a different country. Thanks for watching my video. Feel free to click the links here to watch the next video of the playlist, continue to the next playlist, or subscribe.